In this video, we will discuss how to determine the empirical and molecular formula of a hydrocarbon based on information given from a combustion analysis. As you might remember, a combustion reaction is one in which you have a hydrocarbon and it will react with oxygen in the air. And combustion reactions are kind of interesting because they always generate at least two of the same products, and that's going to be CO2 gas and water vapor no matter what. And to take that one step further, what's also interesting is that the carbon that's in CO2, all of that carbon, if you look back to how this reaction goes, all of that carbon must have come from the hydrocarbon. That's because reacting with oxygen gas is just O2 and it has no carbon to produce CO2. Additionally, all of the hydrogen that is formed in water came from the hydrocarbon as well. And so you get this really interesting thing where if you think about it, if you had Pop-Tarts for breakfast this morning, Pop-Tarts have a lot of sugar in them. And the carbon in that sugar of the Pop-Tart that you may have had this morning is actually now you're breathing it out through carbon dioxide that you exhale. And so that's kind of a weird thing to think about, that you ate sugar in Pop-Tarts, but now you're breathing out the carbon from that sugar in the form of CO2. And then also the hydrogen that was in your sugars or in your Pop-Tarts is actually being breathed out as water vapor, or at least some of it is being exhaled as water vapor. So that's just kind of interesting. But we're going to use this idea that all of this carbon in the hydrocarbon turns into CO2, and all of the hydrogen in the hydrocarbon is converted to water to help us out to get some information about this hydrocarbon, specifically its formula. So let's look at this first example. We are given a 1.5 gram sample of hydrocarbon, and it's going to undergo combustion to produce 4.4 grams of CO2 and 2.7 grams of water, and we need to determine the empirical formula. So before I dive right into the math, I'm going to go through and I'm going to kind of set this problem up so you can better see what is exactly going on with all these numbers. So what this problem is telling us is that we have some hydrocarbon and it's combusted, and that means it's reacting with oxygen, and a combustion reaction is going to give us CO2 gas and water vapor every time. And what they tell us is that the mass of my hydrocarbon is 1.50 grams, the mass of my CO2 is 4.40 grams, and the mass of my water is 2.70 grams. And with that, you may be looking at this right now and say, it seems like the law of conservation of mass is broken. I started with 1.5 grams, and I'm somehow producing, 7.1 grams? But what we could do is we could do a little bit of subtraction. We could get the mass of the oxygen in the air that actually reacted. But we will not need that, so we won't bother with that. Okay, what we're going to do is we are going to use the CO2 data and the water vapor data to help us figure out the formula of our hydrocarbon. So this is just going to be a regular empirical formula question where we do percent to mass, then mass to moles, divide by small, and then we might have to multiply till whole. We're given masses here, so we don't have to worry about percent, so we'll start at step 2, just mass to moles, and I will take my 4.40 grams of CO2, and I will convert that to moles. There's 44.01 grams of CO2 and 1 mole of CO2. And then I'm going to take 2.70 grams of water, and I'll convert that to moles of water. There's 18.02 grams of water for every 1 mole of water. And I want some information on just carbon. and then I want some information on just hydrogen. And right now what we have is we've got some oxygen in there. That's really going to throw things off if we continue any further with the oxygen. So what I'm going to do is I'm going to get rid of oxygen, and I'm going to use this key idea. And here's what the idea is, that if I look at CO2 and that every one molecule of CO2, that is also going to be equivalent to, that's going to give us just one atom of C, or of carbon. And if I have one molecule of water, that's going to give us 2 atoms of H. That is our key idea here. We only have 1 carbon in CO2, but we have 2 hydrogens in water. So what I'm going to do is I'm going to take my fence and I'm going to do one more step, and I'm going to say, okay, in 1 mole of CO2, there's just 1 mole of carbon. Whereas in 1 mole of H2O, there's going to be 2 moles of H. Okay, so now I've just turned it into the atoms. And so I have 0.100 moles of carbon. I have 0.300 moles of hydrogen. I'm going to divide by the smallest moles, which happens to be carbon here. And when I do that, I'm going to get 1 and I'm going to get 3. And so my empirical formula is CH3. Okay? Let's do one more example. And in number 2 here, I am given a 0.250 gram sample of hydrocarbon, and we're going to combust it. And we produce 0.845 grams of CO2 and 0.173 grams of water. So let me first set it up to help me out, and then I will worry about the math. So I have, and actually what I can do is I can just go up here. It'll be the same type of problem, and I'm going to just make my life a little bit easier here. And I've got my reaction. I've just got to change some numbers, but it's the same problem. 0.250 grams. We produce 0.845 grams of CO2 and 0.173 grams of water. I really only care about my CO2 and my water data. Okay, so what I'm going to do is I'm going to take 0.845 grams of CO2 and I'm going to get it to moles. I'm not given any percents here. And then I'm going to take 0.173 grams of water, and there's 18.02 grams of water for every 1 mole of water. But I need some information on just carbon and information on just hydrogen. So here's the step that's a little bit different. That in 1 mole of CO2, if I look there, there's only 1 carbon. So there will be 1 mole of carbon. And when I math that out, I get 0.0192 moles of carbon. And then in 1 mole of H2O, there are going to be 2 moles of H, and the reason why is that there's H2O, and so when I math that out, I get 0.0192 moles of H. I'll divide by the smallest one, which happens that they're both the same. And so when I math that out, I'm going to get 1 for carbon, 1 for hydrogen. And so my empirical formula is going to be CH.